Alright, we're going to be looking at the problem on the bottom of page 3, where we're going to be adding the vectors together mathematically. So you can see here that I drew out each of the vectors. A is 2 feet east, B is 4 feet north, and C is 6 feet at 45 degrees north of west. So when we find resultant 1, by finding the sum of all the vectors, a plus b plus c, what we're going to do is we're going to break each of these vectors into x and y components, and then we're going to add up the x vectors, x components, we're going to add up the y components, and then we'll get a resultant from that. Okay, so the first thing we're going to need to do is just make a table here that corresponds to the y components and the x components. Okay. So on the left side here of this table here, I'll be the y components, and we'll have this for vector A, vector B, and vector C. Okay. And what we'll do is we'll put the subscript for what vector this corresponds to. So those are all y, and these will be all x on here. So looking at the y component of A, if you look at vector A, it's completely horizontal. So there is no y component of A, so that one's going to be easy. So that one's going to be 0 there. Looking at B, it's all y component. It's going up. So this one will be 4 feet on that one. And looking at C, this is the one where we have to use trig because C is going up into the left at an angle, so we're going to have a y component here, call that x component there, C sub x, and then a y component going straight up here, call that cy, and this angle is 45 degrees. So to find our y component, it's going to be opposite of our angle, so we'll use our sine function. Sine of theta is equal to cy over the hypotenuse of C. C sine theta is equal to cy. Okay. So we'll write that directly in here. Okay. So cy is going to be equal to C, which is 6 sine of theta, which is 45. Okay, 6 sine of 45, and it's to the it's going straight up, so that'll be a positive. Let's just make that a positive to remind us. So this is the y vector of A, y component of A, y component of B, and then y component of C. Now for the x vector components, let's go ahead and do this. The vector A is all x component. Okay, so that's going to be 2, and it's to the right. For B, it's all vertical, so there is no x component, so that's going to be 0. And then for C, we have to find this component right here. Since it's adjacent, we'll use the cosine function. So we end up with 6 times cosine of 45. And since C of x, the x component of C goes to the left here, that we need to make sure that's negative. Don't forget to do that. Always double check your signs. So then what we do is we're going to add these up, and since these are going to be added up as the resultant, then we'll call r sub y. And over here we'll add these up and we'll get a resultant called r sub x. So go ahead and do the calculation. And after I added these up, I got 8.2426. And on my r of x, I get a negative 2.2426. Okay. So these are going to be my y component and my x component of the resultant. Now what we need to do is bring these back together now. Okay. So we're going to combine these resultants up and figure out what the resultant is. So let's start with the x here. It doesn't matter which one you start with. Your angles just might be a little weird, but start with the x here. It's going to be to the left. So I'm going to draw. Here's my x component right here. Okay, that's r sub x. My y component is a positive 8, so it's going to be a lot longer than my x component, and it'll be positive. Okay, so there's my r of y. And now my resultant is going to be the sum of these two components. So remember, I add them tip to tail. I start here, I end at the tail right here. And this is supposed to be a straight line, represents my resultant here. There it is. Call this r. Okay. So now what we do is we need to figure out what r is. To do that, we know the y, we know the x component. Using Pythagorean theorem, a squared plus b squared equals c squared, we can find the resultant. Okay, so it'll be ry squared plus rx squared is equal to r squared. Solve this for r, I get the square root of ry squared plus rx squared is equal to r. Okay, plug in our numbers. Get the square root of 8.2426 squared plus negative 2.2426 squared. This negative, you're squaring this negative, so this will end up being a positive number. Okay, you do the math here, and you should get 8.54 newtons. So this represents the magnitude of r. Okay, so we know the magnitude of r. However, we do not know the angle of r. We don't know this angle right here. We have to figure out this angle, theta, right here. Okay, so what we'll say is it's 8.54 newtons at, okay, some angle. We'll fill that in, and you got to figure if it's north of east or north of south, or what is this, or south of west. This angle right here represents north of west, because if I'm going straight west, the angle represents going north from that west, straight west there. So what we'll do is we need to find this angle. We know the opposite and we know the adjacent, so we're going to use tangent. Okay, so tangent of theta is equal to opposite, ry, over the adjacent, rx. I know ry and rx. I need to find the angle. I'm going to use the inverse tangent function. Inverse tangent of ry over rx is equal to my theta. Okay, let's plug our numbers in. Ry is 8.2426 over my Rx of negative 2.2426. I believe it's okay if you put a negative here. I don't think it matters. Plug that in your calculator. Plug this in your calculator, you get 74.78. It's a negative, but that doesn't matter. Don't worry about just take the absolute value here. So here's my angle, and since I'm measuring this angle right here, I already have my north of west set up. So running the 3 sig figs, I get 74.8 degrees north of west. So this is our final answer here. It's kind of a multi-step problem, okay, but this is what you end up with. 8.54 newtons at 74. Oh no, this isn't newtons. This is feet. Sorry, feet at 74.8 degrees north of west, and that's actually what you should have gotten. You should have got near that result in the top when you did this on the floor in class. Okay. This next problem, then, I'm gonna let you try to do this on your own here. Okay. You're doing the same thing we just did, except you're instead of using C, you're going to use the opposite of C. So what's actually going to happen is, looking over here, this will end up being negative, and this will end up being positive. So do the exact same thing, except you have a negative x because of the c right here. You're adding the negative. So and for c of y would equal 6 sine of 45, where c of x is going to equal, oh, I'm sorry, there's a negative here. It will be a positive 6 cosine of 45. Do the same thing, and you should get this answer right here. All right, see you on Monday.